Welcome back, students. In this video, we are going to solve more board problems. In our last video, I discussed about the approach to for different types of problems. Kindly check the video before coming to this video. And presently, as I told, we are solving board problems, and I'll be picking up questions from this question bank. You can use your own question bank, and practice makes you perfect. So practice as many problems as possible. And even as I do this video, please pause the video, practice this. Simply seeing may not help you much. So I'm not covering every question. I'm just picking up one representative sample from both simple and complex and covering in these videos. Do pause the video, try the video, and then see the answers. So the first problem is 1 plus cos square by sin square is equal to cosec square to cosec square a. So by looking at both, you can understand that this belongs to trigonometric identity 1. Whoever came to this video directly, kindly check video of part 9, 10 and 11 to understand properly the three trigonometric identities before solving these problems. So as I told you, there is trigonometric identity 1, and by seeing cosec it looks like there is even identity 3. So let us see how to solve the problem. I am going to split the denominator part into both parts of this equation. Like a plus b by c is equal to a by c plus b by c. The same way, the sine square I am going to split it across these two parts of the numerator. 1 by cos square 1 plus cos square a by sin square a is equal to 1 by sin square a, that is this part, and then cos square a by sin square a, this is the second part. 1 by sin square a is inverse trigonometric ratio, it is cosec square a, and cos by sin is cot square a. But the format whatever you had given on the right hand side has only cosec and not cot. This cot can be converted to cosec easily by using trigonometric identity 3. So I'm going to substitute trigonometric identity 3 in place of this cot square a, and the equation becomes cosec square a plus another cosec square a minus 1. Adding this both cosec square, it becomes 2 cosec square a minus 1. So the second problem is I have to prove sin a minus sin b divided by sin a plus sin b plus sin a plus sin b. That is inverse. Whatever you see in the first part of the equation becomes inverse in the second part of the equation. In this case, there is nothing straightforward but just add both by adding the denominators, and I have to prove it as this is the RHS. So here in both the denominators I can find sin a minus cos a and sin a plus cos a, which is nothing but a plus b into a minus b is equal to a square minus b square format. So in the denominator I put sin square a minus cos square a, and when adding this terms becomes multiply, like sin a minus cos a into sin a minus cos a becomes the whole square, plus similarly the second term becomes sin a plus cos a the whole square. Now I am going to expand each of these equations by using a minus b whole square and a plus b whole square format. This sin a minus cos a is equal to sin square a plus cos square a minus 2 sin a into cos a plus the second part of the equation a plus b whole square I am going to apply here. So it becomes sin square a plus cos square a plus 2 sin a cos a, the whole divided by sin square minus cos square a. Now when I am adding both, this negative term and this positive term gets cancelled, and you will have 2 sin square a as well as 2 cos square a when you add it. Well, let us see now the equation. This gets cancelled, and 2 sin square a plus 2 cos square a divided by sin square. Why I am converting this is, in the numerator for the right hand side, in the denominator for the right hand side, I find only sin square. There is nothing for cos square. So I am going to use the trigonometric identity 1 in the place of cos square and convert it to sin square. So this cos square becomes 1 minus sin square a. Please refer video 9 to understand this part of this conversion. So in the denominator it becomes sin square a minus 1 minus sin square a. By adding both, the denominator part becomes 2 sin square a minus 1. Similarly, on the numerator, I am pulling out 2 separately, and within the bracket I am putting sin square a plus cos square a, which is nothing but 1. So the resultant equation is 2 by 2 sin square a minus 1, which is your right hand side. Thus it is proved. Problem 3. There are two parts of this problem. So one part I'm leaving it for you to do it yourself. The first part I will be handling in this video. They have shown you, they have told you to prove that b square x square minus a square y square is equal to a square b square if they have given two equations. X is equal to a into sec theta and y is equal to b into tan theta. So what is the approach to this problem? See, you know, sec and tan are connected by trigonometric identity 2. For better clarity, refer part 10 of this trigonometric lessons. And so what you'll be doing is you don't have a value of sec theta and tan theta straight away. So you'll first figure out the value of sec theta, tan theta. Then you square both of these values and subtract it. Sec square minus tan square theta is equal to 1. You are going to use this equation. You are going to subtract both. So let us see that in practice now. So sec I'm going to find out by bringing this a to the left hand part of the equation and making x by a. X by a is equal to sec theta and similarly y by b is equal to tan theta. Okay, I'm going to square both. Secant square is equal to x by a whole square and tan square is equal to y by b whole square. And now to bring in the trigonometric identity 1, I have to square and subtract this. Secant square minus tan square theta. So secant square is x minus x by a whole square minus tan is equal to y by b whole square. So x by a whole square minus y by b whole square is equal to 1. Now I take the denominators. Add the denominators, add both this fractional equation. When you add it, the a square, in the denominator you have a square plus b square which multiplies with the other part of the equation 1 and it comes here as a square b square, and on the numerator you find b square x square minus a square y square. So thus you prove this equation whatever they have given. So you can similar way solve the second part of the equation as well. Problem 4. This is a little bit bigger but it's straightforward and easy. They have given cosec A cot A is equal to P and they have asked you to prove the value of cos A is equal to P square minus 1 divided by P square plus 1. So this cosec and cot are related by trigonometric identity 3. I think you need to refer part 11 of the video to better understand this equation. So from trigonometric identity 3, cosec square theta minus cot square theta is equal to 1. This is nothing but a square minus b square format. I split it into a plus b into a minus b. So cosec theta plus cot theta into cosec theta minus cot theta is equal to 1. I have the value of cosec theta plus cot a as p. So I'm going to substitute here and find out the value of, I think I made a mistake. I should have followed the value of a. Kindly note all this theta becomes a. It's a mistake. Sorry. All this theta should be replaced with a. Okay. So now I can find out the value of cosec a minus cot a is equal to 1 by p. So I have two equations in my hand. One is cosec a plus cot a is equal to p and cosec a minus cot a is equal to 1 by p. So I can add and subtract and get some values. Now when I add both these equations, I get this cot cancelled. This cot gets cancelled when I add both. It becomes 2 cosec a and plus cot a and minus cot a becomes 0. So that's how I get 2 cosec a is equal to p plus 1 by p and adding both by taking the denominator. P is 2 cosec a is equal to p square plus 1 by p. Cosec a is nothing but sin a. So I invert it and find out the value of sin a. Sin a is equal to 2p divided by p square plus 1. But whatever is required is cos a, not sin a. So what I am going to do is now I am going to subtract both the equations. When I subtract both the equations, cosec is going to get cancelled and I am going to left with 2 cot a. So when I subtract both the equations, I have 2 cot a, p minus 1 by p. So 2 cot a is equal to p minus 1 by p. I am going to add it and it becomes p square minus 1 divided by p. Cot a, this 2, I am going to bring it down to the denominator part. Cot a is equal to p square minus 1 divided by 2p. Cot a is nothing but cos by sine. I am going to substitute this value of cos a by sin a is equal to p square minus 1 divided by 2p. Sin a I am going to take it to the other part of the equation. Thus cos a is equal to p square minus 1 divided by 2p into sin a. In the previous part, we found out the value of sine A, which is nothing but 2p into p square plus 1. So that I'm going to substitute here. That's what you find out here. So cos A is equal to p square minus 1 divided by 2p into 2p divided by p square plus 1. This 2p and 2p gets cancelled and you are left with p square minus 1 divided by p square plus 1. Thus, you have proved cos A is equal to p square minus 1 divided by p square plus 1, which is exactly what the problem wanted. In the coming videos, we'll discuss more board problems. Thank you and bye till then.